Okay, in this lab we're going to be coming in and smelting 3 different compositions of an alloy made up of lead and tin. Now, I have gloves on, and these are rubber gloves. You don't have to have these on working with the metals, but I do want you to know we are working with lead, and lead can absorb into your skin over time if you have heavy exposures. We do have soap that will ionize the lead, so if you want to just use your hands and go over to the sinks and wash with the ionizing lead, that'll be suffice. If you're really concerned, you may wear a set of gloves doing this. Again, we are working with lead here. The levels that we're going to be exposed to are very minimal, and when we smelt this down, we're going to be in a vent hood, extracting the fumes, and so it's going to be fairly safe for us. So let's follow our safety procedures there. So for this demonstration, I decided I'm going to wear gloves, and I'll go ahead and wash with the D-lead soap. So in your lab sheet, you're going to have to make 3 different amounts of material consisting of lead and tin. While we're at the station, we're going to tear out how much one of these trays weigh. And to do that, just push the yes button here, the power button, one time, and it is now teared out. I'm going to add some material here, and I can tell I'm a little bit off. I need to be 2 grams for this case here. So what I'm going to do is add some more material, and I'm going to carefully cut that with the scissors and make sure that I don't add too much. So there I can see I'm about 0.2 off. I'm going to come in and add a little bit more. I'm getting closer. I'm going to continue to keep cutting and adding material. I'm getting a lot closer. And I just barely need anything right there just to make it right. Okay. So right there, I'm in tolerance. I'm at 2 grams. Anything that's extra, just put in the extra tray at the machine that somebody else can use for their amounts they need to weigh. We want to keep the lead and the tin separate, so we'll probably have one station for measuring lead and another station for measuring tin, so we keep the 2 apart. So I know how much I have here, and for this experiment, I need to have for this experiment, I need to have 10 grams of material total. So I'm going to do a double check on this and zero out and tear out my scale. I'm going to add some lead. I'm going to add some of my tin, and I should be within the tolerance of 0.05 plus or minus for my grams there. So that's going to be the right composition I need for my alloy. So what I'm going to do is go ahead and weigh out, and I've already done it over there, the different ratios that I need to have. I need to keep track of those. Okay, so I've finished weighing out my samples, and this is the sample with the most lead. That's going to be sample number 3. The one with the next to the most is going to be sample 2. The one with the least amount of lead is going to be sample 1. And so I'm going to go ahead and add all the tins to the 3 compositions. So this is going to be sample 1, 2, and 3. Keep those lined out, so when we go over to the furnace, we're going to start with sample number 1 first, smelt it, then 2, then 3. We're at the smelting hood, and we need to talk about safety. First thing is airflow. We have a door that raises up, and if drawing air into that area so we don't smell the fumes and inhale those, and those will be vented out safely. If you raise the door up too high, an alarm's going to go off. If you hear the alarm going off, raise the door back down to a point where the alarm goes off. Don't reach up and turn the alarm off. So we know we have proper airflow going up and away, and we're not inhaling the fumes from the melted lead and the alloys. That's one thing I want to point out is whenever time we melt a metal, some of it can become atomized up into the air, break free, and we can be inhaling that. So we want to be careful of those kind of things. The other safety point we want to have is you need to have your lab coat on. I have my brown one. You'll have the blue one. The other thing is, for this lab, we're going to use welding gloves on here because we're not going up to 1800 degrees Fahrenheit. We're actually staying around 600 degrees Celsius. Still pretty hot, so we don't want to touch anything over here because it's going to be hot. Again, we're going to be pouring metal in this situation. And what we're going to do is we're going to be pouring these nice little round pieces right here. They're basically a bullet mold that we're going to do, and we're going to pour our samples, and so you have to keep track of which sample is which when you pour these. Now, assume everything is going to be hot here. This is going to be our mold that we're going to use, and it comes apart, as you can tell. So we don't want to use any tools to pry the part out of here. These are going to go together, and so put your mold back together and turn it like this, and your mold will stay together. We're going to put our mold into this metal tray right here, and that's where we're going to pour our metal into this mold. When we get done, it's going to be hard to get the sample out of there because you're going to have some metal in the countersunk portion of the mold. What we're going to do is push this lever this way, and it will shear that off, and then we can open it up and we'll have our finished part in there. So that's how we basically hold our part. So make sure this handle, when we want the mold closed, is pushed to this side. So now I have my mold ready to pour, and what I'm going to do is I have 3 different glass vials over here. The first one is for our sample number 1. The second one is sample number 2, and then the third one is for sample number 3. Now we're going to be reusing these little crucibles, these glass tubes, for everybody's experiments. So what we want to do is make sure we don't cross-contaminate. So I have on top here my sample for sample 1. That's the one with the least amount of lead. And we have a glass stirring rod here as well. So once I have my metal in my crucible, glass crucible, I'm going to set it inside there. But before I do, I'm going to attach this clamp right here and leave that on there. That's going to let me be able to pick this up, take it out, and pour this. And we're going to let that sit right there inside the little furnace here. We're going to time it for about 2 minutes, and we should have molten metal. Now what we're going to have to do is we're going to have to take our glass rod, and we're going to have to put it inside there and stir that. So once we stir it 10 times, we're going to set that down here on this tray carefully not to break it. So at this point we waited our 2 minutes, and as you can tell, I now have some molten metal in there. So I'm going to carefully take my stirring rod, put it down in here, and stir that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to remove my stirring rod out, lay it down, and now I'm ready to pour. So this is my mold. I'm going to bring it over here, and I'm going to pour into the mold there. Okay? Get everything out that you can, and then return the empty crucible, glass crucible that we're using over there. Now our metal is cooling off, and if you look, it has a nice little shrink feature on the top because it acts as a sprue/riser on top. I'm going to take this. Now this is going to be hot, and I can feel the warmth a little bit through here. I'm going to be careful not to touch the metal portion. I'm going to come in here and break. You notice I broke the top off, and there is my sample. Now I didn't have the mold all the way closed, and I don't want to reach out there without the use of tools, but you can see I've got some flashing. I didn't have my mold completely closed. That's okay because you're going to be able to take this and break this off fairly easy off of your part. So you can use the tools here to remove that extra flashing if you do that. Now all the extra metal, this is still going to be hot. I'm going to take it over and quench it in water before I touch it. Okay, I took my sample over and I put it in water, and so this is now cool, and this is sample number 1. So I'm going to want to keep that and identify it as sample number 1. Now I have little bits of metal left over, and there's 3 trays in the back. The one on the left is for sample 1. So one of the things to clean our stirring stick is to take this gold pad and rub it till it comes clean, and it'll be ready for the next use. Now we're ready for crucible number 2. We're going to get our mold closed back up, and this time we're going to close our mold up and hopefully not get any flashing. So what I'm going to do is, I've already done sample 1, now I'm going to do sample 2. We're waiting for the metal to pour, and one of the things I'll probably want to do is go ahead and write on here, because we know this one's cold. I'm going to write a number 1 on there with a Sharpie, so I know that this is sample number 1. I will do that for each sample, 1, 2, and 3 as they come out. Once we've smelted our parts, what we're going to do is come over here and mount them. And now you've already had a lab using the mounting presses and the polisher machines. I'm just going to do a quick review to do some reminders on how to use them. But the first thing is, I recommend using 3 different colors of resins, 1 for each sample, 1 for 1, 2, and 3. That way you can identify those fairly easy because they all look just alike. Now then, you're going to use the mounting press to do this. Quick reminder, you've got a button here that will select left or right. You can raise and lower using the yellow buttons, the ram, and that's going to allow you to put your resin into the machine. You're going to use the funnel and complete scoops of these. You're going to fill each one up, level them off, so you've got those 2 scoops to pour in there. The other thing is just hitting the start button. It's going to take a little over 5 minutes to mount your part. Remember, unscrew it and hit raise the ram, and it's going to pop it out and eject your complete puck. And once you have your pucks made, you're going to be using the grinding machine, and we're going to mount our samples in the carousel, and we're going to use the brass grind method. That'll work fine for these lead tin alloys. And you're going to need to make sure you have the right consumables. You're going to start off with the foil pad for stage 1, and then here we have on the machine actually the Largo pad, which is green, and the machine will apply the chemicals correctly for you. Now when it comes to polishing, you guys are going to use the brass polishing method, which is going to require you to start off here with the MD mole pad. And again, these are probably going to be dry, so make sure you wet these heavily before you install them and run them. The first stage is going to use the diamond polish, automatically applying that for you. The last stage is going to be using the MD Chem pad for the brass polish, and you're going to be applying the oxide polish, the OPS, and you're going to need to have it dripping out there so it can polish your samples for you. Again, once we get done with that, we're going to take them over the parts washer, wash everything, and now we're going to go over and etch our parts in nitrile. And what we're going to do is come in here and etch them using 3% nitrile. Again, you need to use safety gloves and have the vent hood open just enough to let airflow go through without setting the alarm off. So we're going to use nitrile right here. We're going to keep all of our chemicals in the vent hood. We don't want to double dip with our Q-tip, and you're going to find these are going to etch fairly quick. You want to get that nice and wet, and you're going to open up that grain boundary. And remember, you want to turn it a little bit frosty and then take it over. You want to put some methanol on there and neutralize the acid. So we just came from putting our acids on while it's still wet. We don't want the acid to dry. We're going to neutralize it with the methanol, and we're just going to let it dry, and then we're going to take it to the microscope and look at our microstructure. Okay, we're at the microscope, and again, you've used this equipment in past labs, so we know that we can put our sample up here, and we're going to have to match the nose pieces that we set to the nose pieces on the software using the Elements programs for the Nikon software. That way, when we take measurements, either in dimensional or even object count, everything's going to come out apples and apples. Now then, I've got one of my samples up there, and I'm looking at a sample, and I believe this one looks like it's all one continuous eutectic or looking phase, all thumbprint looking, and I can see the grain boundaries. And so I really don't need to do an object count for this sample because it's pretty much 100% one phase. Now another sample that I might have, and I'm going to focus this in here, is going to have multiple phases. You can tell I have some of this lighter area here and some eutectic in there. So what we're ready to do is come in here and count the objects that we have. I'm going to go to View, Analyst, Controls, and then there's an object count. We're going to select the little plus arrow right here and pick the areas that we want to have selected. And if you notice, it pretty much selected those grains that I wanted, those lighter grains, and right here it tells me a percentage of that. Now you can play with the histograms and play with how you pick those until you feel satisfied that you have the phase that you wanted selected in red, and that's going to tell you that percentage of phase there. And so you're going to do this for each one of your samples, and you can record these images again. You can come in here, and if you want to capture this on here, I would recommend hitting the Windows key, Shift, and S, and then you can do the full screen capture, and you can save that to your hard drive using the snip command. Now, one last thing I want to point out is a lot of people are going to say, well, that's how much lead or tin I have. No, that is how much phase you have. You're even going to be looking at steel samples, and you're going to be seeing ferrite and pearlite. So that doesn't tell you that that's carbon and iron. What you're going to have to do is that line, the tie line lever rules that we have on the lecture where we talk about calculating the percentages of phases for hypo and hyper eutectic or eutectoid alloys, depending on if we're going from a solid to solid transformation or a liquid to solid transformation, and we can count those percentages phases. So what you want to do is compare your calculations with what we're doing here in lab. Well, I hope that helps out, and that's going to get us through this portion of the lab.